Be ready to ask questions off page 364. Make sure you're listening closely. A couple of things. Find the sum of the interior angles of a hexagon. How do we find the sum of the interior angles?
Minus 2.
Use this formula. Now it's alright if you use the chart that we wrote down last time, but you gotta know the formula so that you can find it for any polygon, not just the ones that are on the chart. What goes in place of n? So we do 6 minus 2 times 180. Have your calculator out. Help me. What's 6 minus 2?
4.
4 times 180.
720.
So the sum, how many angles does a hexagon have? 6. The sum of the interior angles of a hexagon always will add up 720. No matter what six-sided shape you have in the world, the six angles are always going to add up to 720.
If I keep pulling on it, it just keeps
Well,
going.
quit messing with it for a minute and I'll help you out. Find the measure of each interior angle. How are you going to find each? This is what you got to be careful of on these.
Divide.
You're going to take that number, if you look up here, each interior angle, still take that same formula, n minus 2 times 180, and once you have it, you just divide it by how many sides it has. So we already found the 720 up here. What am I going to do with that?
Divided by 6.
Divide it by 6. So if we draw a regular hexagon, that means a hexagon where all the sides and all the angles are the same, then what do we know about that angle right there?
It's 20.
It's 120 degrees. Every angle in that regular hexagon is 120 degrees. Number 3, find the sum. This time we're doing exterior angles. Sum of the exterior angles of a hexagon.
Yeah, you just want the answer on the board.
No, where at?
Right there next to the screen.
Exterior angles equal 360.
yeah.
Divided by n.
Oh, I did the first year on good.
So you got to be able to do this. Does everybody see what they did wrong if they messed it up?
Yes. Yeah.
Because you got to be, for the whole chapter, you got to be able to do this. On the homework, questions, problems you want to see worked off of page 364. I highly suggest those of you sitting there, like Hunter, had an excuse for the last 6 assignments. I would get his book out and follow along and try to understand something. Which one? 47? Writing expressions. Write an expression to find the sum of the measures of the interior angles for a concave polygon. Explain your reasoning.
Yeah.
So this one, we're not going to do a whole lot with concave. This is more a problem to just try to see if you can think your way through something. You have a concave polygon. I'm trying to draw the first one they have there. So it looks something like that. Is that
Yeah.
close? How many sides does this polygon have?
4.
4 sides. If it was a convex polygon, what do you know about a 4-sided figure?
It equals 360.
All the interior angles add up to 360 degrees. Well, this one's got this angle that sticks in, so it's not going to add up to 360. What do you think might happen then?
Interior angles be bigger. Because it's like that.
What do you know about that angle?
It's bigger.
It's bigger than 180.
Yeah.
All right, so maybe could we do something like, if you're just writing the equation, is there really any way to separate this and say, okay, it's always gonna be this? Or could that angle sorta just be about anywhere? Could be about anywhere, but as it goes in, what's gonna happen to these two angles?
Yeah, it's smaller.
They're getting smaller, so it's probably gonna be, there's gotta be something that's around 360. Alright, or some use of that 360.
Can you put a line on the 2 points to make another shape?
What if we had this? What do you know about those two angles?
Yeah, 180.
Add up to 180. How about those two angles?
180.
They add up to 180. Add up to 180. Now, if we did this, what should be true about? How could we do that here? Let's see. Trying to. What do we know about just this part of this angle? It's 180, and then we got this part over here, right? So could we do something with that and maybe try to find it? Could we say, okay, 180 interior and exterior, 180 interior and exterior, 180? How many 180s are we gonna have here? 4. So 4 times 180. Where'd the 4 come from, do you think?
4 sides.
4 sides, so actually it might just be n times 180, right? Plus, I think that change them. Plus, what other part of the angle do we need that in? That small part right there. So maybe we call it x. Now here's where you gotta be careful. All that should equal how much? We got whole 180 here, whole 180 here, whole 180 here, another 180 here.
Alright.
720 plus the x. Maybe we even should do this. That's another 180, right? So now we got 180, 180, 180, 180, 180. How many 180s do we have now? 5. What's 5 times 180? 900. Could we do that? Would that work? Because if we do this, this is 180. And I circled this. I shouldn't have. That's 180, right? Interior and exterior. That's 180. This is 180. From here to here is 180, and then from here to here is 180, because we got to get that little part in there somehow.
Huh.
So could we maybe set up something like that?
Yeah.
Yeah. Is that sort of pain in the butt? Yeah, that's why we don't use concave polygons. Other questions? That one was just to get you thinking. Yeah, so we ain't really no answer. It's sort of what they ask you to try to come up with something on your own. Which of the following angle measures are possible interior angle measures of a regular polygon? Explain your reasoning, select all that apply. What's answer A?
162.
Answer B? C? 175?
No, 75.
Oh, 75. 75, D?
40.
Now they want to know which one of these can be an interior angle for a regular polygon, whatever it is. Interior angle of a regular polygon.
It's not A and B. Yeah.
Can't be A and B, you sure?
Yeah.
It's over.
I'm sure 162 was like polygon, right?
I don't know. How could we figure it out?
Just divide.
These are the interior angles. I'll tell you the easy way. These are the interior angles. Would it be easier to deal with the exterior angles? So if 162 was an interior angle, what's an exterior angle gonna be?
Like 17, 18.
18? Just subtract from 180, right? What's an exterior, oops, got my X there. What's an exterior angle gonna be here? How about here?
Like 105.
5, here. So now, sometimes it's easier to deal with the exterior angles instead of the interior angles because look at the exterior angle formula. What's the exterior angle formula?
360 divided by
360 divided by the number of sides. So what we could set up now is we know that 360 divided by n should equal 18. If n comes out to be a whole number, then it tells us it works. If n comes out to be some decimal, then that means it's not going to work. Because can you have 7.2 sides? No, it's not going to work. So we could set this up now. We could have just used the 162. We could have set up this formula. N minus 2 times 180 divided by n. That's each interior angle formula, and that should have equaled 162. Which one of these ways is going to be a little easier? The top one, that one up there. All right. So even though we knew the interior angle, find the exterior angle, and then solve it from there. Easiest way to solve this, put a 1 under that. Now what do you have? You cross multiply, you have a proportion, right? You have a proportion. What's 360 times 1?
360.
What's n times 18?
18 and
How you going to solve that?
divide by 18 on both sides.
What do you come up with? Use your calculator. What is it? 20? Can a polygon have 20 sides? So that one would work. Set up same thing on this one. What's our equation going to be?
170.
360 over 8.
Oh, wait, yeah.
360 over 8 equals 9 over 1.
360 over n equals 9 over 1. 360 equals 9n. Guaranteed, yesterday in our teachers meetings and stuff, a lot of the teachers are saying that a lot of students can't do problems where there's more than one possible answer. You got to be able to do that. Sometimes there's a better answer. You got to be able to pick which one's your best answer. What's this come out to be?
40.
Is that all right? Is that possible?
Yeah.
Try 75. What's our equation going to be this time?
75.
What's our equation going to be?
It's 360.
360 over n equals, oops, 105. Cross multiply, you get 360 equals 105n. 3.42. What's that tell you? Can't have a polygon with sides 3.42, so there is no regular polygon in our world that has an interior angle that's 75 degrees. Now, are there polygons that have angles that are 75 degrees? Yeah, they just can't be regular. Can't be where all the sides are the same, all the angles are the same. Let's try this one. 360. I'll tell you what, let's even try this one out the long way. Let's do n minus 2 times 180 divided by n. That should equal each interior angle, which is 40. Could we sort of do the same thing here and put a 1 underneath that? What's 40 times n give you? 40n equals, what's 1 times all this mess going to give you? That mess. N minus 2 times 180. What are you going to have to do to solve from there? Distribute this out. First distribute that out. You get 40 in equals 180 in minus 360. Now what are you gonna do?
360 minus 180 and then.
Can you
You-
subtract the 180 on both sides, right? Get all the ends on one side. I'm out of room down here. When you subtract 180, what are you gonna get on the left-hand side? Negative 140 in equals negative 360. Now what? Divide by negative 140. A negative divided by negative is gonna be positive, so we don't really have to worry about that. What'd it come out to be? 3.57? 2.57? Is that possible? So this one won't work, that one won't work. Those two will. You were completely wrong. So, a 20-sided polygon, a 20gon, has an interior angle that's 162 degrees, if it's regular. A 40-sided polygon, if it's regular, has an interior angle that's 171. There is no polygon that has regular polygon that has an interior angle of 75, and there is no regular polygon that has an interior angle of 40. Other questions?
Seventeen.
17. It's probably the last one. Help me out, Gunner. You know how to do this one. First thing we gotta do, count the sides. How many sides does polygon have?
6.
6. What do you need that number of sides for?
Plug it in 6 minus 2 times 1.
99% of the time you're gonna have to use this formula first. Alright? So 6 minus 2 times 180. What is 6 minus 2? 4 times 180. Didn't we just get done doing this? 720. Well, what's that 720? Does that mean our answer is 720?
Adds up to all.
That means all 6 of those angles add up to 720. Once we know what they all add up to,
You need to add 121, 96, 101, and 162.
slow down. 121 plus what?
96, 101, 162. Yeah, and then you add that all up. And
Now, be careful now. You still need something else.
Equals 720 plus X.
Plus X. You still need that other angle. And this is the reason that I actually want you to write it out this way. Even though most of you are saying, oh, I'm just going to grab my calculator, add them all up and subtract. Because if you don't write them all out, then you're going to end up messing up on some problems. Because what I want to do now, once I know that this equals 720, is I want to go back and do this. 1, 2, 3, 4, 5, 6. What's that tell me?
6 times.
It had 6 sides, 6 angles, so I know I got them all. I didn't miss any of them. Because are you going to miss one every now and then?
Yeah.
Yeah. Now let's add all these up. What do you end up with? 570. Now we got 570 plus.
X equals 720. Can you just do 720 minus 570?
Now what do we do?
Minus 70, minus 720.
Bobby's still on the fact that Mr. Eversole doesn't have a clue what he's talking about.
150.
Because she's gonna do it. X ends up being 150. And this is the problem I'm foreseeing. If you're not careful,
Yeah.
because Bobby wants to skip a couple of steps, and if you're not careful, what's going to end up happening is they're going to throw in an extra X on a problem. That's going to mess you up. All right? Or you're gonna come up with this 570 right here and think that that's your answer when you add them all up. That's not gonna be true, all right? So you gotta be careful and make sure you're getting the correct answer, the answer that they want.
570 would be a, it's not an angle.
That's true. There is such an angle, but not in our class.
Is that
But-
4 dimensions?
But I've had people tell me in the past that segment AB was negative 17 centimeters long. So you should know that that's not possible also, right? All right, go ahead and start copying this down, parallelograms. Rough weekend, Gunner.
Everyone had a rough weekend.
I couldn't sleep.
Then the crap out of my cheek would have been done yesterday.
We'll probably get in trouble for Saturday.
Oh, because of yours yesterday, that was my cheek. I've been,
Don't want to real bad. They're really trying to get us all in trouble.
it's a who posted.
Oh.
He posted a picture on the
Shelby started on the student.
Today.
Your slide.
She supposed to trip all of them.
Bobby, what does your shirt
What are we running now?
Huh?
What does your shirt say?
It says big, big red pants.
Start writing, because you got about
Yeah.
10 seconds.
I was get suspended. Yeah, and yours will take your girls off.
Mine says big
It
red.
doesn't specify.
They're not starting their homework on the side.
Shut up, Sam. What sport do you play?
Like it's
Pretty sure
already-
you quit football.
I did.
It's just for you.
You should play next year. We're gonna win a few games.
All right, parallelograms. We're going to start a chart, and we really won't start it today, but what it's going to have, we're going to have quadrilaterals. What's a quadrilateral? Four-sided figure, four-sided polygon. Off of quadrilaterals,
Did you show us this chart?
parallelograms, probably at some point I did.
Because they added something.
Right. And then we're gonna add other things as the rest of this chapter goes on. We're gonna add things onto this. What you gotta remember. What kind of shape is that?
A square.
No,
Quadrilateral.
it's a quadrilateral. Alright? And this is the problem that we're gonna have, because when it comes test time, I'm gonna ask you what that shape is. And a bunch of you are gonna say it's a square or rectangle or whatever. Don't go by what it looks like, go by what you know about the shape. So by the end of this chapter, I should be able to give you any four-sided figure, and by the information that you know about that four-sided figure, you can tell me what it is. Alright? So know and use properties of a parallelogram, prove a figure is a parallelogram, that's what I was just talking about. And you're gonna have to do stuff on a coordinate plane, or on a graph. What's that tell you that we're probably using again?
Rents.
That's true, but what else? If we're on a graph, what have we used every time this year? Distance formula, midpoint formula, slope formula. Gotta know all those. That's why we've been going over them so much here lately. All right, go ahead and write this down. Parallelogram. Parallelogram is a quadrilateral with both pairs of opposite sides parallel. Now what some of you are saying, and we'll talk about it a couple of classes from now, what some of you were saying that I showed this to you before was that they changed the definition of a trapezoid, or what we use as a trapezoid. This book, though, doesn't change the definition. They kept the definition the same as what it's always been. But when we get to it, we'll talk about.
Isn't it like we've got at least one pair of?
Right. The old definition was exactly one pair of parallel sides. The new definition is at least one pair of parallel sides.
So I'd make a square.
All right.
That's stupid.
So a square would be a trapezoid.
That's stupid.
Well, and I didn't know this at the time because I argued the same thing, that it was dumb to change but every other country in the world calls a trapezoid
Hey, sister.
four-sided quadrilateral with at least one pair of parallel sides.
So this is America. It's like India or China or something like that.
But if everybody else uses it, then.
Don't worry, Trump's cut that off.
Alright, parallelogram. Quadrilateral with both pairs of opposite sides parallel. This is the symbol for parallelogram. So anytime you see that little symbol, that's going to tell you that the shape is a parallelogram. That's the only shape, the only four-sided figure that we're going to talk about in this chapter that has a symbol. When you name it, first, what do we know about these arrows again?
They're parallel.
That means that these two sides are parallel, and the doubles tell us that those two sides are parallel.
Yep.
When you name a four-sided figure or any polygon, you've got to go around it either clockwise or counterclockwise. All right? So I named mine parallelogram A, B, C, D. Started here, went to there, went to there, went to there. What's another way that that shape could be named?
A, C, B.
A, D, C, B, I heard. Would that work?
No.
Yeah. What's another way?
B.
DCBA.
D, C, B, A. Would that work?
Yeah.
Yeah. Any of those. Now notice, when I draw my little shape here, this is why we only got one symbol. Does that look like a parallelogram?
No.
No. But there's not going to be any other little four-sided figures that have their own shape or have their own symbols.
Could you do?
So when we have this, we want to know for sure, even though my drawing and probably your drawings when you're drawing the little parallelogram won't look real good, there's no other thing that it could be. So it has to be a parallelogram. If it's got four letters and it's got a symbol out in front, it's a parallelogram. Does that make sense?
Could you do like BABC?
Yep.
Okay.
So parallelograms, the only one that's got a symbol. As we go through this, the only bad thing about that is when we get to a four-sided figure, if it's a rectangle, then you got to do this. Rectangle, QR, MP, or whatever the rectangle is. You have to actually write out the word. Now we'll probably, because I'm pretty lazy, we'll probably abbreviate rectangle, R-E-C-T. You didn't want a pen? I can give you a pencil, I just thought a pen would be. Alright, draw this picture. Diagonals, we talked last time about diagonals. Diagonals of a parallelogram, how many diagonals is a parallelogram going to have? Two.
Same.
Three. What looks to be true about the diagonals in that parallelogram?
They're congruent.
They look congruent?
Yeah. Yeah.
So if we started Ian right there, and he was going to walk the purple diagonal, and Sam started walking at T, and he was going to walk the orange diagonal, Ian, you're telling me that you guys would walk the same distance?
No. NT is congruent to SH, and NS is congruent to TH.
Now, the diagonals, are they the same?
No.
No, in a parallelogram, the diagonals are not the same. All right? They're not the same. But, is there anything that looks like it's true about? Maybe, they might be perpendicular. Not always. What happens here? Looks like those two parts are the same length, right? And it looks like these two parts are the same length. And that's true with the diagonals. Now you got to be careful because the diagonals of all these four-sided figures that we're going to cover this whole chapter, there's going to be something different about them. If I draw a shape and I tell you it's a rectangle, now Ian starts walking and he walks that diagonal. Sam starts walking here and he walks that diagonal. Does it look like they walk the same distance now?
Yeah.
Yeah, so in a rectangle, the diagonals are the same. Alright, but in a parallelogram, are they always the same?
No.
Now, where you gotta be careful at is a rectangle is a parallelogram, but it's a special kind of parallelogram. So in all parallelograms, the diagonals are not the same. Alright, write this down.
What does that mean? Is a square?
Square is a parallelogram also. What's the other shape that's a parallelogram? Where it said
Right.
rectangle, square,
Rhombus.
rhombus. Make sure, as you write these down, make sure you think about what you're writing. So let's read this first one before you get too far. What's this say?
If
Parallelogram.
So if you have a parallelogram, then what do we know? Opposite sides are congruent. These are the things you're going to have to be able to use. So if you have a parallelogram, opposite sides must be congruent.
We gotta prove how we're gonna do proving coloring.
Yep. Notice these first four, I put them in black. These are the theorems. These are actual theorems. These last two just come from the definition. They just come from the definition of a parallelogram. But these are all properties of a parallelogram. All things that as soon as you see this symbol, as soon as you see that little parallelogram symbol, then you know all of these things. And on the next slide, this is why I want you to read them carefully, because on the next slide, we're going to start right here with Silas, and he's going to tell me something about the shape that I have up on the next slide, it being a parallelogram. And you can't use anybody else's, so by the time we get over there to Wyatt, he's probably going to be down low, and he's going to have to really pay close attention. Yeah.
Say, pay close attention.
I can't read anyways. I'm riding with a bus.
what does that little square mean?
It's a parallelogram.
That works.
I was just making sure I put it down right.
Did you write like the first line?
Yeah, I did, but I was just making sure. Mr. Eversole, can I get a drink?
You better hurry up.
Huh?
You better hurry up.
This class, I'm gonna start saying no to drinks, because you guys don't wanna ask too much to take advantage of it. I said that last class, didn't I?
Yeah.
I gotta quit myself.
I would want her to take a drink of my water.
This class really don't
Chuck
look
said.
that high, but
You did, you ask every day.
yeah, well, just not every day.
Yeah, you're right, you didn't ask yesterday.
To-
Didn't ask all the like
Go.
maybe.
Get in trouble with that.
It's emergency. It's an emergency.
Right, on a parallelogram. This is our parallelogram. What can you tell me about these two sides? They're congruent. What else can you tell me about these two sides? They're parallel. What can you tell me about these two sides? They're parallel. What else? They're congruent. What can you tell me about this angle and this angle? They're congruent. That's what this second one says. If this is a parallelogram, then these opposite angles, the angles that are opposite each other, have to be congruent, have to be equal. What can you tell me about these two angles? They're congruent. Consecutive angles. The angles that are next to each other. So point out two consecutive angles for me, Silas. Those are opposite angles. Those. Does everybody see that? Ones that are right next to each other. What's got to be true about them? They got to be supplementary. They add up to 180. So what has to be true about these two angles right here? They add up to 180. How about these two angles right here? They add up to 180. The diagonals. When we draw the diagonals in here, I don't have my diagonals drawn in on this one, but the diagonals bisect each other. Right? Now, does that mean the diagonals are the same? No. The distance from here to here is not the same as the distance from here to there. But we know that when we draw in both diagonals, the distance from right here to that point where they meet in the middle, and then here down to this corner, has to be the same. The diagonals bisect each other. So each diagonal split into two equal parts. Opposite sides are parallel. We already talked about that. The sum of the interior angles. What do you know? How many sides does this parallelogram have? 4 sides. So what do we know about all 4 of these angles? They always add up to 360 degrees. They always add up to 360. Now this is where Wyatt probably wants to be paying close attention, because on this next slide, we're going to go through this. So I'm telling you that NTHS is a, what's this symbol tell us? It's a parallelogram. So starting with Silas, you've got to name something for me that's true on this shape. Give me something specific for our shape. You should have the easiest one. Say it again. Segment NT is congruent to segment SH. Everybody agree with that?
Yeah.
Opposite sides. So he told us this one. Those two are congruent. Matt, next one. Give me something else.
TB is congruent to BS.
TB, segment TB is congruent to segment BS. So this segment is congruent to that segment. Everybody agree with that?
Yeah.
Yeah, because the diagonals bisect each other, so these two parts have to be the same. Bobby, give me something else.
N and S, since they're like right next to each other, they're gonna be supplementary and money.
Now, we can't name an angle N and angle S, so you're gonna have to name it better than that. So you're trying to name this angle right here, right?
Yeah.
So name, how many letters?
1. It's got 1 letter.
3.
T and S.
Quit helping her. Now name the other one, or I'm sorry, you said supplementary, didn't you?
Yeah.
TNS is supplementary to,
T and S. HSN. Would it?
say it again.
HSN.
Does that work? Does everybody agree with that? Yeah. Give me another one, Sam. Segment NS is congruent to segment what? TH. A lot of people upset because that's one that they were going to use, right? All right, Gunner.
Segment NB is congruent to segment BH.
Segment NB is congruent to segment BH. Everybody agree with that? Yeah, because the diagonals bisect each other. Probably could have done this. Those two are congruent. Those two are congruent. Give me something else, Hunter.
Angle TNS is
Angle TNS, what? Is that what you said, TNS?
TNS and BHS
bunch
We
of stuff,
haven't
but there's
done-
still a whole bunch more.
If parallelogram, then sum of interior angles equal to 360. We have to explain it.
Probably really don't wanna do that one, do you? Cause how many angles you gotta name?
Four.
4 of them.
Do vertical angles.
It's all kinds of stuff you can
Oh,
still
yeah.
do.
Vertical angles.
So name me a pair of vertical angles. Say it again.
TNS.
That's not gonna be vertical to anything.
What? It's a rough life. Already got one going, let's go.
It's like 6,000 more.
We did the opposite side.
Yep, I already did all both pairs of opposite sides. Well, sort of.
NT is parallel to SH. There we go.
Oh.
Segment NT is parallel to
I
what?
already did that.
Segment NT is what?
I know. I said I know.
Next one, Natalie.
NS is parallel to GH.
We have the.
To parallel to what?
No, we don't.
GH.
That's what I was writing on that for. Good job, Nat.
What else? Next one, Ian.
MBS is vertical to TBH.
Angle NBS. Make sure you guys use your symbol. Now, let's not say that they're vertical. What do we know about them if they're vertical?
Right.
So angle NBS, Hunter, you watching? Angle NBS, oops, NBS at this angle.
Wow.
Is congruent to which angle?
TBH.
TBH, this angle. All right, Wyatt?
Angle N is congruent to angle H.
Now, bad thing with that, you're right.
Angle TNS is congruent to SHN. or
TNS is
Yeah.
congruent to what?
SHT or THS.
SHT.
Something like that.
All right, so he used the fact that this whole angle and this angle are opposite angles, so they have to be congruent.
I didn't wanna do it yet because the sides weren't congruent yet, but couldn't you do the triangles inside of it?
Yep. So what do you know about these two triangles? They're congruent to each other. What do you know about these two triangles?
They're congruent.
They're congruent. If these two triangles are congruent, now I'm gonna use something different, but then we know that the angles that match up are congruent. We said that these two sides are parallel to each other. Well, if those two are parallel, these two are parallel to each other. We use this as a transversal. What can you tell me about that angle right there and that angle?
Oh, they're
Congruent.
They're congruent. What kind of angles are they again?
Z.
They form at Z, alternate interior angles.
I have a question.
What could you tell me about these two angles?
They're alternate.
They're alternate interior, so they have to be congruent. We could do the same thing going the other way, and use these two parallel sides. So what do we know about these two angles? They're congruent, so on, so on, so on. Is there still a whole bunch of other stuff that we haven't said?
Yeah.
Yeah, what do you know about
In.
this angle and this angle?
They're
NB.
They're supplementary. What do we know about this angle and this angle? They're supplementary. What do we know about this whole angle here and this whole angle up here?
Congruent.
They're congruent. Whole bunch of stuff. Soon as you know this is a parallelogram, that's the only thing they told us, is that it's a parallelogram. Alright? We know all kinds of information, and you gotta be able to use all that different information. Sometimes you're gonna be using the fact that, hey, these two angles have to be congruent. Sometimes you're gonna be using the fact that this segment has to be the same as that segment. Depends on the problem. Guess what?
Would them, triangles, would they be angle bisectors also?
No. So that, and that's a good point. If this is our diagonal, does it bisect this angle?
Oh, I don't know, no.
Does it look like it? No. If it's a parallelogram though, if it was a rhombus, then guess what happens? Yes, then it bisects. And we're going to talk about that when we get to the rhombus shape. Right. Ways to prove a quadrilateral is a parallelogram. Ways to prove a quadrilateral is a parallelogram. 5 ways to prove something is a parallelogram. Got to be able to do this. Got to be able to prove something is this certain shape. Draw the little shapes out here, the little parallelograms. One of them I've already marked. I didn't mark the other ones because it was going to be too much trouble. And they want to know, is this shape a parallelogram? These are the 5 ways that you can show that it is a parallelogram. Again, the easiest way to show it's not a parallelogram, it doesn't have 4 sides. It's not a quadrilateral. The first one, show both pairs of opposite sides are parallel. So if you can show this, and I'm going to mark these, and you should probably mark them there on your paper. If those 2 sides are parallel, those 2 sides are parallel, then what do we know about the shape? It's a parallelogram. This one I've already got marked. If both pairs of opposite sides are congruent, so that side's congruent to that side's congruent to that side, then we can say, yes, this is a parallelogram. Show both pairs of opposite angles are congruent. So if we can show this angle is congruent to that angle, remember with the opposite angles, they have to be the ones catty corner from each other. And this angle is congruent to that angle. If we have that information, then we can say, yes, this is a parallelogram. Show the diagonals bisect each other. So if I draw in this diagonal, I draw in that diagonal, I'd have to know this part's congruent to that part, this part's congruent to that part. Now I don't know if this book does it or not, but every other book I've ever taught out of, they're going to give you a shape, and it's going to look like this, and they're going to draw in the diagonals, and they're going to do this. And then they're going to say, is that a parallelogram?
No.
No. Do the diagonals bisect each other? No. All right? Even though these 2 parts are the same and these 2 parts are the same, they're not being bisected. So don't let them catch you with that little trick of switching them around that way. And the last one, this is probably the hardest one. If we can show that these 2 sides are parallel and that same pair of sides are congruent to each other, then we know it's a parallelogram. So it's sort of a mixture of the first 2 up here, but only using 1 pair of sides. All right, only using 1 pair of sides. Think you can handle all that, Silas? All right, these are just those same theorems. I don't know that we even really need to write these down. I even forgot the number. I'll pass that phone to me here in a minute. If you don't put it away.
I'm not on it.
You were a second
I
ago.
was.
And it seems like this is a common thing every day that you're in here.
I'm not having
You're gonna be really upset with me if I have to take if opposite sides are parallel. So this is the way you write it out. If you're writing, if they say, is this a parallelogram? And they want a reason. This is what you write. If opposite sides are parallel, then is a parallelogram. So that would be the shortest way to write a reason for this being a parallelogram. Each one of these. And that's up to you. It might be a good idea. If opposite sides are congruent, then is a parallelogram. Because some of the problems are going to ask you, is this a parallelogram? Give a reason why, or explain why. These would be your explanations. If opposite sides are congruent, or I'm sorry, if opposite angles are congruent, then it is a parallelogram. If diagonals bisect each other, then it is a parallelogram. If one pair of opposite sides are congruent and parallel, then we know it's a parallelogram. So if they ask you to write a reason, that's what you're going to write. One of those 5 things. And this is the shortest way you could write it. Just showing you the shortest possible way. Yes, it's a parallelogram because these opposite sides are parallel, or these opposite sides are congruent. Midpoint and distance formula. It might not be a bad idea to write those down again. I know that every single one of you's got them all memorized.
Literally reading that like that.
Yep. And still, everybody, when I see it on a test paper or something, Sam, there's still minus signs in the midpoint formula and plus signs in the distance formula.
Not me, cause if I feel like I did it wrong, I just erase it and get a 0 on that one.
Good, thank you.
Well, if I'm gonna be wrong, then you might as well not have it anyway.
Hey, I didn't put I don't know in any of those questions.
Yeah, that's where it's gonna start deducting points off your test.
Yeah, he said he's gonna take 10 points off of it.
So with the midpoint formula, don't make the midpoint formula harder than it is. Both of these formulas you're going to use if you're given ordered pairs. Well, you always have to have 2 ordered pairs to use either one of these 2 formulas. With the midpoint formula, you just take the x coordinates, the first number in each set of parentheses, add them together, divide by 2. You're finding the middle. That's all there is to it.
On that one.
Y's, add them together, divide by 2.
On the one thing, like on the test, the graph one, we were supposed to use the midpoint instead of the distance, but I used the distance, and I got it wrong.
So you got to know, when do you use a midpoint formula? When you're looking for what? Midpoint. When do you use a distance formula? When you're trying to find the distance or the length of something. So know which one you're using this one at this point, this one at that point.
What's that one formula that's like b plus or minus the square root of 4 times AC?
Quadratic formula.
Yeah.
The other one, you might want to write this one down. The slope formula. Again, slope formula, m equals, you subtract the y's on top, subtract the x's on bottom. Now, a lot of the times we don't use the slope formula to find the slope because we can just count. We can use rise over run to see if the things have the same slope.
Does it have to be switched for the slope?
Right. For slope, notice on the slope, everything else, the x's come first. For the slope formula, the y's are on top and they come first. All right, write this down. You're going to draw a little graph there on your paper, and we're going to do this problem. Just use that graph paper then. Grab another sheet, just hole punch it so it gets into your binder. Doesn't have to be a great looking graph or anything. But since you got it, you could. Look at my numbers here. What do we got? From -3 to 4 y, -4 to 3 up. So we could probably be about right in the middle, couldn't we? That's my x-axis. That's my y-axis. Somebody tell me how to graph point A.
-3.
You go left 3,
Left 3,
up 3 left.
up 3. You should be graphing this on your paper. That's A. Then what? What's B?
You go over right 3.
Right 3.
That's it.
That's B. Then what?
You go over right 4,
4.
and then down 4.
1, 2, 3, 4. That's C.
You
Is that
go-
C?
Yeah, then you go right, left 3.
Left 3.
Yeah, left. Yeah.
And
Oh.
Down 1.
down 1.
That's 2.
Oh, sorry. Ignore that. That's D. We connect this. We want to know, is this a parallelogram? And Ian's going to look at it and decide, and that's not what I want, because it's going to ask you why.
Because AD is not parallel to BC.
Okay, if Ian sees that, if he sees that segment AD over here is not parallel to BC, for it to be a parallelogram, both pairs of opposite sides have to be parallel, right?
Yep.
So if we look at this and we go segment AD and we say we're going to find the slope of it, how can I find the slope of AD? All right, rise over run, right? How many spaces up do I go?
4.
4. How many over do I go?
0.
So that's the slope of that, which it really doesn't have a slope because it's vertical. But now let's find the slope of segment BC. We go up 1, 2, 3, 4, and left 1. So slope is 4 over -1. Are those two the same?
No.
And this is what you're going to have to do. Slopes not the same. So what's that tell us?
They are not parallel.
So are not parallel. Now, does that answer the question? No, we still got to answer the question. What was the question?
Is ABCD a parallel?
So is it a parallelogram?
No.
So is not a, and you can use the symbol, is not a parallelogram. All right? Other things we could have done. Could we have found the length of this side and the length of this side?
Yep.
Yeah. Could we found the length of this side and the length of this side? Yeah, what should be true about the lengths of these two sides? They should be the same, right? These two should be the same, right? Now, something that I like doing that nobody else likes doing is for this to be a parallelogram, if I drew in the diagonals here, what should be true about that point right there?
Should be
Bisect
halfway.
both.
It should be the midpoint of
Each line.
both of them. So could I find the midpoint of this one and the midpoint of this one? And when I find them, what should be true about those two ordered pairs?
Same.
It should be the same. See, I like doing that because the slope formula to me is easy. Because if I take A and C, I just look at it and I go, all right, negative 3 plus 4 is 1. 1 divided by 2, 1/2. 3 plus -4 is -1. -1 divided by 2 is -1/2. So that's the slope of, or I'm sorry, that's the midpoint of that one. What should the midpoint of this one be if that's a parallelogram? It better be that same thing. So let's do B and D. What's 3 plus a -3? 0 divided by 2? 0. Then 0 plus a -1 is -1. -1 divided by 2?
0.
-1/2. Are those two the same? Not the same, so what's that tell us about this shape? Not a parallelogram. There's 5 different ways. Remember those 5 ways that you wrote down to prove that it is a parallelogram? Well, those same things would prove that it's not a parallelogram. All right, draw this shape. Put all that stuff in it. gonna find everything that we possibly can. Is there a lot that we can figure out about this shape?
Yeah.
Yeah, a whole bunch. Somebody tell me the first thing. Let's find x first. What's an equation?
2x plus 2
Okay.
equals 5x minus 10.
2x, very good. 2x plus 2, this should equal that, because what do we know about the diagonals?
They are.
They bisect each other, right? 5x minus 10, I'm gonna solve that real quick. Subtract 2x on both sides. You end up with 2 equals 3x minus 10. Add 10 to both sides. 3x equals
12.
12. Divide by 3, what's x equal?
4.
4. Once we know what x is,
Just plug it in.
plug it in. How long is this segment?
10.
10. So that segment's 10. How long is this segment? 10. How long is this segment?
7.
7. What other segment does that tell us?
And B is 7.
NB has to be 7, so we can put that in there. Now, is that all it tells us?
No.
Now, let's keep going. What can we do with this real quick?
That's, you can just plug in 4.
Plug in 4, what's that?
80.
80, so that's 80 degrees. How about this angle?
40.
40 degrees.
SH is 13.
SH is 13, everybody agree with that? How did Matt know that that's 13? Opposite sides have to be congruent. TH is 8. Is that all we can find?
NHT is
NHT, that's this angle right here, is how much? 80, everybody agree with that?
Yeah, then the
Look,
other side, that's 40.
if you have those are alternate interior, what's this angle? 40.
STH equals 48.
STH, that's this angle up here is 48, everybody agree with that?
Yep.
Now you guys have found the easy stuff, let's see if you're smart enough to find the little harder stuff.
What about, it's finding area, obviously not gram, different from finding square.
Not really.
So it's just 104.
So area is length times width, which is 8 times 13, and what is it?
104.
104. I'd accept that. That's and square units. It's not something that I was even thinking about finding.
TBH equals 32 degrees.
TBH. That's this angle right here. Is how much?
32.
32. Everybody agree with that? How'd you come up with that?
Add them all, add those two sides, 26.
What do you know about that shape right
It
there?
has to add up to 1.
Has to add up to 180. 3 angles of a triangle have to add up
So
to.
then do the other side, because 80 plus 48.
This is 32 over here.
Never mind, 52.
52.
Yeah.
52. Matt said it gave us the wrong answer. So that's 52. Could we find this angle?
Yeah.
180 minus 52. What's that give you? 128. That means this angle up here is 128. What else?
You can do 128 plus 40.
Okay.
And then whatever that is, you take that minus 180. And that's what the other one's going to be.
So what's that going to be?
Well,
You're not tricking nobody. We're talking. Focus.
12.
12. About this angle.
12.
How'd you find 12?
Because you do 128 plus 40.
Those two have to
And
be
that equals
subtracted.
168. And then minus 180.
Now, could we have found it? Could you have done this? What do you know about this whole angle and this whole angle.
There's supplementary.
There's supplementary, it should add up to 180, so this is 40 plus 80 plus 48. Subtract that from 180, and that should have left us with that, and we could have found that angle. And then what do you know about these two angles? They're congruent, they're alternate interior. Is there anything else we can find? Have we found every side, every segment in this picture? Every angle in the picture? Yeah. All kinds of stuff you know. Once you know the shape is a parallelogram, you know all that information. All right, your assignments on page 372 and 381, 2 separate pages. Again, interim reports come out Friday. Some of you can't afford to miss another assignment. Grade's going to be not good the way it is probably.